Hello there, and welcome to another Swift Toolkit video. Today we have Rambo as a guest. Hey Rambo.
Hey, how's it going?
Good, and you? Thanks for joining.
No worries. Thanks for having me.
Sure. Today we're gonna talk about CLI tools and the argument parser, and we also are gonna do a hands-on overview of an existing project that Rambo wrote and put on GitHub, and we're gonna see how we can leverage the argument parser to make it even better and even more Swift-like and more type safety maybe. So I first heard of Rambo's passion for the argument parser in one of his podcasts in Portuguese, and I immediately thought we could do an exercise about this. So I pinged Rambo and he agreed. Right? It's one of your favorite tools.
Yes, I love writing little command line tools to solve little problems or automate simple things. I guess I could use shortcuts, but if you're a developer, it's easier to just fire up Xcode and do a thing with argument parser than it is to try to figure out how shortcuts works. So I use it all the time.
Maybe you also have some packages that you already have built and you wanna use them.
Yeah, and sometimes I'll have a particular problem I want to solve that will be useful in many places. So I naturally will start out with a package or move something into a package. And it's also nice to have another target in that package, even if it's just like for testing purposes. So you have like your unit tests or whatever, but you can also have a little command line tool that's basically like a command line interface to the package so that you can exercise the functionality or just leverage it somewhere, including in shortcuts if you want to.
Yeah, on the Mac, I assume.
Of course. Unfortunately, yeah.
Yeah. Yeah, all right. So we spoke initially about two tools, right? One of them is a Mac app that you have for inspecting XE assets files.
Well, the compiled version of XC assets,
yes,
so
yes,
the .car file.
Exactly. Yeah. Do you wanna show it a little bit?
Sure.
Or maybe talk a little bit about what came first. The UI came first. This is an interesting use case because it lets us show how you can have side by side a real app sharing code with, by real I mean a macOS UI app and a command line tool app.
Yeah, and in this case, the actual, like you mentioned, the real app came first, so it was already an app. And it's a quite old app, actually. I'm not really proud of the code. If you look into the code, it's kind of messy, but it works, and it's been out there for a while, has been receiving contributions from other people. And not that long ago, I think it was earlier this year, my friend Chris mentioned he wanted to do some sort of automation involving extracting assets from these compiled asset catalogs. And with the app, he couldn't automate it because it was just a GUI app and it didn't have like Apple script or shortcuts or anything like that. So I proposed to him that I made a command line version of the app, basically. Yeah. So and there are multiple approaches you can take when doing something like that. And in this case, I chose to have the app itself be its own target, like it already was, but then have a separate target that's a command line executable, which is then the command line interface.
Which
and then you can,
which is interesting noting also that it's not a pure SPM project, right? It's a regular old school Xcode project.
Right. Yeah, and that's also, it's good that you mentioned that because people sometimes are under the impression that like, argument parser tool has to be a Swift package, and that's definitely not the case. And I I would say the majority of my projects that use Argument Parser are not actually Swift packages, but are just like regular Xcode projects. And I even have like, just like I have with like I have AirBuddy, which probably many people know, but it's a Mac app. And in the AirBuddy project, I have a command line target that uses Argument Parser. And it's like an internal tool that I can use to debug the app, like run commands against the app and like add fake devices and things like that.
Instead of clicking things in the UI and...
Yep. So you can have it side by side with your app, even if it's just like an internal thing you use for testing. So it gives you a lot of flexibility as to how you approach it. And so we mentioned the different approaches, and another thing you can do, which is a little tricky, but it's definitely doable and might be the preferred way depending on what you're doing, is you can have your actual app target be runnable from the command line. And there are several different ways to detect when it's running on the GUI versus when it's running on the command line. And then if you run it from the command line, it goes and runs an actual like argument parser command parser and does its thing. And if you run it from the Finder or whatever, then it just launches the app. So that's also something you can do. I would do that if, like, let's say you have like your app target and there's a lot of code in it and it's not very modular, and it will be a huge task to like extract everything
into different modules.
That's a good workaround. But if you can, I would suggest just having like a command line tool.
I see. And the other project that we thought could be a good use case, it's called ocrit. You
can call it ocrit if you want to.
That's
some
easier.
People call it that. But when I was creating the project, I thought OCR it. So you OCR things with it.
So that one is a pure SPM packet project. And as you mentioned, you wrote it a while ago before you learned a few things about the more advanced use cases of the argument parser, or not the basic arguments, flags, options.
Right.
So we thought it could be a good thing to iterate over it, and could be a good example of going beyond basics with the argument parser.
Right, and OCR, I think, is a great example, not because it's particularly good or anything, but just because the reason I wrote it was to solve a problem that I had, and it was... So I was living a rental apartment, and when they did like all the checks and stuff like that, they said that there was like a payment missing in like the middle of my rental, which was like 3 years or something. So but I have a folder in my Dropbox where I save all of my receipts when I pay for something via the bank. So I thought, well, I know I paid it, but I need to find the receipt.
Don't know where. Yeah.
Exactly. But I knew it was in that folder, and the folder contained a bunch of images, basically. Images that like the app from my bank exports. Yeah. So I needed a thing where I could quickly just give it a directory, and it would take the images and output text files. So I wrote OCR it in like 20 minutes or something, like the initial very basic version, ran it and used like grep or something to search for...
To find
and I found the receipt, and I was able to send it to them. So it saved me some money.
Yeah, that's a cute story. So let's get hands-on with it. Let me share my screen here. Okay, so this is ocrit. That's the README explaining what the tool does, and we can see that there's only one package here, which is the argument parser, and it also has a test target, which is very important for refactors like this. There's implementation, and then there is the main struct, the entry point, of this tool. So the first thing I thought here, Rambo, is about output, because output is a string, and sometimes I think it's more ergonomic to use a specific type that has, for example, methods and properties that are focused on this type. So, for example, if it's a relative path, then maybe we could have a method that makes it an absolute path, or maybe checking if it already exists or not, or writing to file, or creating a directory, or maybe I wanna concatenate with a different folder. So all these kinds of things, they're a bit easier, and they're a bit easier to do if we choose types built for it instead of just relying on strings. So
Right.
yeah, so I thought we maybe could use a package as PathKit. There are a few other alternatives. There is path.swift. But they all have the same idea. So I chose PathKit in this case, and this is not a discussion if we should use yet another package and add another dependency, but which I know you like to be simple sometimes, and I think that's the correct approach in many cases.
Yeah, so my take is that for a project like this, I would usually not have something like PathKit, but as soon as you start adding more commands and subcommands, and all of them have to deal with paths and creating directories and checking if files exist or not, it becomes a pain, right? So you need to use some sort of abstraction, and it can be PathKit or it can be a thing you wrote yourself. Something I like to use quite often is just the URL type, although I feel like recently it feels like it's not wanting to work with file paths that much anymore. Like whenever you ask for a path, it wants you to say if you want it to be percent encoded or not,
right,
which is
it has this new they deprecated the regular one, right?
Yeah, so it's and I've seen times when it just like gives you the percent encoded version, even if you didn't explicitly say yes or no for that. So I feel like URL is no longer a very safe way to deal with file paths. There is a built-in path type as well, but the ergonomics of that are not very good in my opinion. So I think in this case, this is a good place
it's acceptable.
to... Yeah, it's a good place to demonstrate something like PathKit. I wouldn't use it in this project because it's a very simple one, but like I mentioned, if you start adding more commands and having to deal with that stuff, it's better to have an abstraction.
Okay. Yeah, so let's try to add it and see how we can change our code. So I'll start by adding a package dependency, and the URL I'm gonna take from here. It's this one, and version we're gonna go with from 1.0.1. And now we have to add the dependency on the target as well. So we go with product. The name is PathKit, and the package is also PathKit. This package resolution passed, so we can go here and we can import PathKit here. So that's a very interesting approach it took here. If there's nothing passed or just a dash, then we go for standard output.
Actually, that's fairly standard actually for command line tools. Yeah, so usually if you have like a dash I or dash O argument, like for input or output, a dash as that argument means standard input or standard output. So it is kind of weird, but it is fairly standard.
Yeah, that's standard. Okay, today I learned. So let's try to keep this. So, but in any case, let's do what I thought we could do is maybe we can declare this as a path, as an optional one. But you're gonna soon see that the argument parser is it doesn't know how to convert a string, which is the argument, into the type of path. So one thing that is very useful here is using the transform parameter in the initializer, and it gives a string and expects a value, and the value is of course path. So we could do let's say arg in, and if we do, so we can do if arg equals dash, then it's nil. Otherwise, so, and here comes the nice thing about path is that we can initialize it with a string. So we're gonna just go with arg. And another interesting thing is sometimes there are tools that accept or don't accept relative arguments. So PathKit has a nice method that is absolute, and if we go into it, we can see that it already checks, does a few checks for us. So the first one is if it's already absolute, it's an absolute path, and meaning by absolute we mean slash user slash my user slash something, instead of just omitting the whenever we don't have the first slash. It means it should be relative to where the tool is running, and that's exactly what the absolute does. Absolute check if it's not absolute, meaning if it's relative, and if it also doesn't have the tilde in the beginning, which means for the current user, then it fallbacks to the current path plus the relative path. So this is something you get for free when using something like this. So
and just so people know, you are using the transform option here, but you could, if you wanted to, conform path to, I think it's expressible by argument, right?
Yes. Yeah.
Yeah. So let's say we had like several commands, then you could do it like that. But if it's in just one place, it's easier to just do this.
Yeah. So we're gonna start with this one, and soon we're gonna go to the expressible by argument to see what it can give us. So if now we cannot run the app, we see that we have an error. So actually, that's another thing I wanted also to cover, which is we do some sort of validation here, right?
Right.
And you told me you learned a little bit about this.
Right, yeah. So when I originally wrote this, I didn't know about the validate methods. I assume it was already there back then. But yeah, so it's easier and cleaner nowadays to just do your validations in the validate method.
Yeah. So that's exactly what I think we can do here. So let's take first of all of this and move here and see what we're gonna have. Maybe other errors, but we'll take care of them. So yeah, so now it's complaining because output is not a string anymore. It's an optional path. So we can do different instead, and we can do let's see how we can do this. We can go and do if output, no, if let output. So if we have a path, guard output exists, and you can make it even simpler. If output exists, if there is an output but the directory doesn't exist, or it's not a directory, then it's gonna fail. So if you go to, wait, we should use this one, right? Because if it's
right.
not, we want to throw if it's not a directory. not only that it exists, we want to make sure that it's a directory. And
we unwrap the output in there and do the check after that, because, well, first of all, we can't do the check without unwrapping it, but also if people remember what we just did, we have a nil output if we're sending it to standard output.
We allow, and we allow an empty one. So and then there's another thing here that you wrote this struct here, right? That conforms to localized error. And this is interesting because, first of all, you use custom string convertible, which when you return the error here, the argument parser takes care of outputting this. And another interesting thing is that usually in Swift, many people are used to do, like, in my error conforms to error, but error doesn't mean you always need an enum. And in this case, you just went for the simple thing. You just created a struct that you initialized with a string. And
I have since evolved that technique. And if you're being really lazy, which we are not in this case, we're doing the right thing. But when I just need I basically have this in every project nowadays. I just extend string to conform to localized error, and I can just throw any string. If you just want to report errors, but you're not actually catching them in the sense of dealing with them, right? Mm-hmm. So you just want to report and interrupt something if an error occurred, I think it's perfectly fine to just throw a string. But in this case,
then you can do like JavaScript. Right?
Exactly.
You can just do throw strings.
I mean, not every aspect of JavaScript is weird. I guess it can be weird, but it's weird in a good way. But I guess what you're leading to here is that argument parser actually has its own error type we can use, right?
Yes, exactly. So for validation, the argument parser has, which is if we go to the implementation, it's just like yours. It has a message and conforms to custom string convertible and returns the message as here. We're gonna see though, maybe there are more changes. We're gonna find out them soon. And then we have to fix something else. There is this output directory URL, and we need to fix it.
We have a choice here, and I'll let you make the choice. And there is no wrong answer, but this right result, if I'm remembering correctly, it calls out to something else, right?
Yeah.
And there's also the input, I guess, which we'll handle somewhere. So we have a choice of how far do we propagate PathKit into the code? Like, do we use it just for the initial parsing as an argument, or do we propagate it into the actual like implementation of the command? And that's a choice. There is no right or wrong answer. It's just a choice.
So we'll have at some point we have this here, right? We have this should output to std out that we can already delete it for now because we cannot. I mean, this actually compiled this comparison here. So probably path.
I guess
conforms,
path is
has an overload.
Literal something. Expressible by string literal, I think it's called.
See. Oh, it has another one with path. Oh yeah, you're right. But it's probably not gonna work as we want here because
now we are only using the dash.
We are changing. Yes.
Yeah. So
let's get rid of this one, and we have to do this decision if we're gonna output to the command to the output or to the standard output, or if you're gonna go to the file. What do you think it's better here?
Well, I think in this case, we can probably remove the output directory URL argument completely from this write
Yeah.
result function.
Because
And
we have it
right.
in the struct level, right?
And the reason it was being passed in like that was because it was originally being resolved within the run function, and now we've moved that over to validate.
To
So
the validation.
if we have reached write result, we have validated that the output is either nil or standard output or a valid output. So this can be just a guardlet, I guess.
Yeah, so we can do here a guardlet output directory URL equals to output question mark URL.
Nice.
And this should work. And you see we don't have any compilation errors. And now is where we're gonna take advantage of the tests you have, because we want to make sure that everything is still working as we intended. So I'm
not sure how good the coverage is, but
yeah,
I think
but
at least we'll see if it works.
Yeah. So let's move over here and we see that some passed. Every test passed.
Nice.
Okay. All right. I was expecting to have an error here in the invalid languages test. Let's run this again. Or maybe we should clean.
I guess we haven't moved the language validation yet.
Oh, you're right. Yeah, we also, so it means that there's no test for this one. Yeah, you're right. When validating, we forgot this one. So this is also validation, right? And we forgot to move this as well. So if we run now the tests, not only this, we also didn't replace here the failure, because this is a validation method.
Right.
So we have to import the argument parser here as well. And let's throw validation error. And now we should see the error that I'm expecting. Okay, so let's see what Xcode is telling us. So it got error code, the exit code was 64, and it was expecting regular exit code 1, which is a regular failure, or generic failure. And if you go here to the argument parser and we see exit failure decode, this is it's 1. But let's see if we have other options. And the autocomplete already suggests us validation failure. So this is exactly what we want. We don't want a regular error. We want a validation error. And now it passed.
Nice.
So that's good.
One thing I will mention, if you go back to where we just replaced the error throwing in the validate languages method
here.
First of all, and this is my fault, but for some reason this extension on VN recognize text request is in the CG image OCR file, which is an interesting choice that I made. But what I would probably do to make this better, which we don't have to do now, I'm just mentioning, is because I don't like that we have imported argument parser within this file, because this is a very inner core implementation file that I could imagine wanting to pull into some other project or library for other purposes. So in this case, I will probably move this validation to a separate file just so we don't pollute the CG image OCR stuff with argument parser.
Okay, so we can do
validation.
What was the type? VN
recognize text request. It's right there. I just read it because I completely forgot the name.
Yep. So we can do plus validation, and we have to import vision as well, right?
Right.
something we didn't mention in the introduction is that this is a tool that if you try to compile on Linux, it won't work at all, right? We are all used to now Swift for Linux and compiling tools and servers, but this is a perfect example of why it's nice to have all this, to have the argument parser running on the Mac, because it uses a framework that is only available on the Mac. And I just realized also that we call this from this method from another one. So here it would throw a validation error, but I think it's okay, right?
And I think you have to, because there is I think this particular method is private.
Oh yeah.
So you have to.
So let's remove
file
this.
private.
Yeah. Mm-hmm.
Yeah, and like you mentioned, it's really nice that you can do this sort of thing, and you can think of many APIs you could use on macOS, and that would be a use for them when called from like a command line tool. So you can expose functionality in a command line tool. Right, yeah.
Yeah.
AV Foundation, like write your own FFmpeg clone.
Yeah. Yes. Yeah, that's a good point. So moving on, I think we can now talk about a step further, which would be what we already, you suggested already, the expressible by argument. And I think that we could maybe use a custom type for the output, because right now we use path. And maybe we want to have this some logic somewhere else. Maybe we want to be more explicit about standard output or not, instead of relying on path existing or not. There's another place we didn't look into, which is image paths. And here maybe we can go with path as well. Let's see what's gonna happen if we do this. It's the same error we got before, that it's not decodable. And using this initializer requires that the type that we use here conforms to expressible by argument. So I'm gonna do this here in this file for now, then we're gonna move this soon. So we can do an extension on path conforming to expressible by argument, and it's soon gonna tell us which method we should use.
And also, if you are using newer Xcode, you have to do retroactive.
Yes, because
because they're annoying. That's because
now we're getting the error we wanted, which is we don't have the init with argument that it's already suggesting here. So we need, basically what this protocol is basically, it says a type that can be expressed as a command line argument, and it requires being able to convert from a string into a type. And the cool thing is, I'm not sure how many people know this, but all numeric types, they already conform to it, and there's not even the need to implement the method on the side of the argument parser, because all these types can be initialized with a string, I assume.
Right, they are doing the conformance on a lossless string convertible. So anything that can be initialized from a string basically gets that for free. And that's a really neat trick that I have used in my own code a lot. If I have like something that I will have to do with numbers, and I want any number type to have that, you can do like binary integer, or you can use the lossless string convertible if it's based on a string. Now, one thing I want to ask you, and I haven't looked into it, and I would say you could probably find an issue in the argument parser repo about it, but it annoys me that this initializer is a failable initializer rather than a throwing initializer. Because sometimes I would like to be able to actually like throw a validation error and say, hey, this is invalid because such and such.
Yeah, that's interesting. That's an interesting question, why they chose this path, this what led to this, because if I pass something wrong, I don't want it to be nil. I want it to tell me what I did wrong as a user of the command line path.
Right.
Okay, so here it's pretty simple what we want to do, how we want to implement this. So we use the same as we did before. We just pass the argument as a string, and we do self equals. And there's something else which, again, as I said before, because we're talking about the context of paths, we want this to support absolute paths, relative paths, sorry. So we also use the absolute method here. And what it's complaining about, okay, makes sense. Now image paths is an array of paths and not an array of strings anymore. So here, instead of this, we can use a key path to simply transform this into URLs. And now image URLs is back an array of URLs, and in a much nicer syntax, at least I think. Yeah. And just for the exercise, I hope you're not attached sentimentally to your code.
Oh,
but
no.
I'm gonna delete this.
No, I love deleting code. It's my favorite exercise.
So yeah, apparently it's safe because we're not using it anymore. So
now, how is the standard output stuff gonna work in this case?
No, we didn't touch it yet.
Right. Oh, right, because you're still using the transform.
I'm still using the transform. Yeah. So now I'm gonna take this into a path plus into another file, and I'm gonna put them all here. I love this new file from clipboard, path plus argument parser, and I have to import argument parser and PathKit, of course. Okay, that's good. It should be compiling again. I'm gonna just build to see things are building. Not gonna run tests yet. And now let's try to do the output type that we spoke about. So this is one of the things that I love about Swift is I can the same for the optional type, right? It's not like we're not in Objective-C anymore where things can exist or not, and or other assumptions that we do sometimes. The more we are intentionally explicit about our intentions, the better. So let's do an output type, and what we want here, Rambo.
So I guess this enum could have two cases, one which would be standard output and another one which would be a path, and it would have an associated value which is a path, right?
Yeah, perfect. And okay, we also need PathKit here. And let's now try to change our output parameter to output. And it's again doing that, complaining about that thing. And now what we want here, we want also to implement expressible by argument in this case. Let's just remove this. And here output, we want a default value.
Right. So by default, it can be standard out.
It was, let's do std output. But it's still complaining that it doesn't conform to expressible by argument. So let's add here argument parser, extension output, expressible by argument. And also we'll need retroactive.
No, because this is
not
our
here,
type.
because this is a type of our own. Correct. Not a type that we don't own. Okay, so if argument is a dash, then self equals to std output. I think we could also do here maybe argument is empty, or not sure this is possible.
Yeah, I don't think it can. I mean, Maybe if you did like -o open close quotes, it would send an empty string.
Technically
but
it is. The
you
argument
shouldn't
parser
do
should
that.
take let's if you do this, your fault.
Exactly.
Otherwise, if it's empty, then we want to do a path. And what we want in the path here, let's declare a path, which is argument, and then let's use this argument, and let's do the same thing we did here with this one. All right, so we have output, and let's see which errors we're getting now. We're having probably other errors. So now output isn't optional anymore, but we did the conditional unwrapping in order to find out if it's standard output or not. And so let's maybe do another extension here and move that logic into properties.
Should we maybe implement this in this extension like just a validate function for output?
We can. Yeah, why not? Let's try. Let's do first the isStd output. So we do switch on self, not Swift, switch self. Here we return true, and otherwise on default it's nil. No, it's false.
False, yeah.
So
now if this was JavaScript, you could return nil there.
Nil, yeah. So let's do output dot isStd output. No, if it's not out as standard output, right?
Right.
And is directory. So now we want to do. Actually, maybe we can do something different here. We can also do path, and this is also optional. And we also we're gonna do the opposite. We're gonna do caselet path. Then we return this path. Otherwise, we return nil because it's not a path. So now we can do. We could not rely anymore on this one. We could do instead if output, if there is a path on it.
I guess you could do an if let, right?
Yes, if let, if there is a path, which is this, and the path doesn't exist, no, is directory again. So now we throw the same error. And this should be it, but we have still another error. It was this output directory. Now we don't have output is not optional anymore, but URL is.
Through path, right?
Yeah.
So you have to do .path.url.
.path, yeah.
Nice.
And this should be it, right?
I think so. And the cool thing is, like we just wrote this fairly quickly, and now this could be used in if we were to add more subcommands to this tool, we could use the same mechanisms.
Yeah.
But this is also fairly reusable. You could like copy this into another project or package it as like a separate library that you can import. So we did this work, and it seems overkill for such a small project, but the cool thing is that we can now use this anywhere, basically.
We are doing the building blocks, right?
Yeah.
We can, yeah.
And this is why I will sometimes take the time to do this. I obviously didn't for this project, but I will sometimes be doing like a simple project, and I will take a little bit of extra time to actually do these building blocks that I can then leverage for other things.
Yeah. Yeah, makes sense. Yeah, so now everything is still passing. That's very cool. Let's maybe do a quick recap. So we learned about the transform parameter in arguments. We learned about expressible by argument. we learned about the validate function and validation error. We saw that it throws a different error. Oh, you wanted to validate. You wanted to move the validation here as well, right? To the here.
We could leave that as an exercise to the viewer.
Yes. So if you're watching this, we're gonna push this maybe into a branch, or there is already a branch with these changes.
I mean, if you open up a pull request, I can definitely merge it.
Okay, cool.
So something else I think it would be interesting to point out, and many people probably already know this, but it may seem like magic when you're using Argument Parser, and even when you have like a Swift UI app and you have like the @main struct my app conforms to app and you have the body in there.
Yeah, we have here the main attribute, right? The keyword.
Which I really love. Like, I really love this way of structuring, like, because you can have a package, which in this case is Argument Parser or a system framework like Swift UI, and it has a protocol you conform to, and that protocol implements a method in an extension called static func main. And this is happening here, but we don't have to write that. Jump into the implementation. Yeah, so
actually async parsable command just has this one, but if you go to this one, it's actually not even this one, it's parsable arguments,
but it will be implemented in an extension.
It's in the extension. Yeah, you're right. It's still in parsable commands, but it's in the extension. Where is it? Let's look for it. There we go. It's indeed parsable command, and this is all the argument parser does. And not all, but the
bootstrapping.
The bootstrapping part is here, and even the async one has its own, and it was right down here. It has an async function and do and catch, and it tries first to make sure that that the type itself is async parsable command. If not, it just runs. If it is, it uses try await. And I covered this in a blog post previously, but maybe you want to do custom outputs, you want to add colors, styling, and you can do this as well. Like you can do main, and a good place to start maybe is, if it's an async parsable command, just copy this and do this here. I'm not sure. And it should be async throws. No, it doesn't throw, but it's async. I'm not sure this was gonna work. Yeah, it works as well. The output part of it,
they made it public precisely because they want people to be able to do this. Yeah, but
there's something annoying here though, that some of the things inside are not so. There's a lot of, for example, message info. They get the message from the info, but I don't think this is a public type, public enum. Yeah, say it's internal, so you cannot access message info.
Call it.
At least you can call exit with error, but you have no control over.
Right.
But it still could, if you wanted, maybe do your own. Let's say take the message here and output as you want, with colors, and you still would have to call exit with the error code.
And it's important to note that, so in this case, we have an async parsable command, which is a argument parser thing, but you could, in any type you want, like you can have it doesn't have to be a struct even. It can be a class, for example. I guess it can even be an actor if you want to. I'm not sure why you want that, but anyway, you can have a static func main, and it can be async, it can be async throws, or it can be nothing, just like non-throwing, non-async, or it can be just throws. So, and of course, you're only going to have one of those, not more than one. And also, you can only have one, per type, you only have one static func main, and it can be one of those variations. And per target, you can only have one type annotated with the @main annotation, which is what we have here.
Right.
And this replaces what you would normally have in your main.swift file or in your main.c, main.m in other languages. So I think it's nice that they have brought the program entry point into the Swift type system and annotations. And this is exactly what SwiftUI does. Like, I mean, not exactly because it's not a parsable command, but SwiftUI inside its implementation has like a static func main that does the initialization of your app and runs everything. And you can even, like, if you have an app, like I mentioned, that you want to be able to run from the command line, what you could do is you remove the @main annotation from your like struct my app, which has like the SwiftUI app body, and you create another struct or whatever type with the @main annotation with a static func main, and then inside of that you decide whether you want to handle it as a command line tool or just run the app. And if you just want to run the app, you call like
you can do this from
myapp.main, and then it will just follow the SwiftUI bootstrap.
Interesting.
Yeah,
that's a nice trick. And speaking of this, let's go back to where we started from the asset catalog tinkerer, which we didn't show before. We just talked about it, but we can see here that there are different schemes, and one of the schemes we have here is ACT, which is a nice name, as it's the acronym of Asset Catalog Tinkerer, and you can see that it's a target as any here in the list of targets in the project, and the type is an executable,
right?
And it depends on the argument parser, it's just not as we do here with an explicit package, is with Xcode's integration, you declare the dependency on it, and here you depend on the library. So that's also another approach one can have.
Yeah, in this case, I already had most of the functionality extracted into this ACS framework. So the ACT target, which is the command line tool, links against imports the framework.
This and not the app.
Yeah, exactly.
Yeah, so it's a pure service and not UI and anything.
Exactly.
That's very nice.
And I do remember, if people go look in the repo, they can probably find, I don't remember if I opened a pull request to myself, which is always fun to do, but either a pull request or the commit or a branch where I did this implementation, you will notice that I did have to change something that used to live in the app target, and I had to move that over to the ACS framework, because I think like the main service that like goes and reads all of the assets was actually in the app target, and the framework was mostly like models and things like that.
Models and types.
There was a little bit of refactoring involved,
and it's interesting because you made it better in the end of the day just by adding another target.
And the reason I had the framework before was because of the Quick Look plugin. So the app already has like a Quick Look plugin that you can press spacebar and see like the preview for an asset catalog. And then since that was the case, I moved some stuff to the framework.
Very nice. And I see that you also use options here. That's very cool. You just it's an option group, and you use the options in this subcommand and this subcommand, and this way you don't need to do input and input. And you can do string. And now you have another exercise. You can also use path here.
Right. And I think something worth noting as well, when you have a command line tool like this one, where it imports a framework that's built alongside the app, and the framework is embedded in the app itself, and it's not like a static library. So it is a dynamic framework in the frameworks directory. So you have to think about how you're going to set up your target so that at runtime, the dynamic linker can find that framework. And in this case, it's embedded inside of the app within the same executables directory as the app. So the run
maybe we
path
can build and see.
works out. Yeah, sure.
What do you say? Which one?
You can build the main app target.
The main app?
Yeah.
So let's failed. Yeah, sign
You
it.
have to change the theme.
Yeah,
that's fine. So in most of my it's in signing and capabilities, and in most of my projects these days, the open source ones, I actually have a better setup for this. And actually, maybe I do for this one, and that's why you're unable to change it there. Oh no, it's yeah. So it's annoying that you have to do this, but in most of my open source projects nowadays, I have a setup where I use the xcconfig files, and people can
and you probably
just
have it
add it once.
And you have it on git ignore, maybe.
Yeah, I have like a template, and yeah, the main one is in git ignore.
So now it's building. Yeah, and it built. Now we can show in Finder. And yeah, we have ACT here. And we have this here. And where is ACS? It's right next to them.
Yeah, so but you should probably go into the actual .app and show package content.
Show package contents. Yeah.
Yeah, so I think it's inside.
Oh, it's also here. Yeah, it's also here. And if we go to this one we can't go into, but
actually go back into the.
It's dynamically linked, you said, right?
Yeah, go back into the app package, because that's where we're going to find everything, because that's what's actually shipped, right? So inside of the macOS directory below library is where you'll find everything. Yeah. So the actual shipping version will not have that like underscore preview or like the debug. That's like debugging Xcode stuff. So if you get like the shipping version, it only has ACT and Asset Catalog Tinkerer. And that's why I didn't have to do any special handling for like the framework. And if folks want to be able to just type ACT in the command line, they can either add this macOS directory to their path or create like a symbolic link in some place that's in their path, and they can just type ACT.
Interesting. Nice. Very cool. Okay, I think you can wrap up here. I hope you all enjoyed the content here and the presence of Rambo. I'm gonna leave links for if people wanna first of all for the repositories, and also Rambo, if people wanna follow you, find out about stuff you do.
Is there such a thing as following on GitHub? So I guess so. You can follow me on GitHub, and I'm also on Mastodon and Blue Sky. We can leave links to those socials. And my blog also. I don't write that often, but every now and then
there are interesting posts about security stuff.
Indeed. So thanks for having me.
All right. Thank you so much, Rambo. See you in the next one.
See ya.